Let's go ahead and get started. What we're going to do today is talk about a few other topics related to Java 8 streams. If you recall what we've covered so far, I talked about what streams were. We talked about aggregate operations and behaviors, talked about a little bit about some examples of how to do this stuff, talked about splitterators, talked a bit about terminal operations that join the results back together again and provide so-called reductions. And what we're going to do today is we're going to talk about something called the factory methods that are used to create streams. And there's a whole bunch of them, about a dozen or so different kinds of factory methods that Java 8 provides in order to create streams. You can do this in a bunch of different ways. There's certain ways of doing it that are very common, and you'll see them over and over again. There's some other ways of doing it that are much less common, but you'll probably run across it at some point when you write code, so it's important to understand how things work. One of the most common ways of creating a stream is by taking a Java collection and then calling either stream or parallel stream on it. So here we have an example where we've got a list of words to find, which is some kind of array list or linked list, and we call .stream on it. That is a factory that will create a stream, and then we'll do some stuff, and we'll end up putting the result back someplace. If you want to do things that run in parallel, you simply call parallel stream instead of stream, and that will go ahead and create a stream that will run in parallel, mapping on multiple cores, as you're about to learn in the next programming assignment, which will be out shortly. By the way, we're getting very close to having the super cool GUI for the programming assignment, which will come out as part of, hopefully, as part of assignment 2B. So you get a chance to watch your code run, and you'll be able to visualize the different ways of doing it sequentially or in parallel, which is going to be pretty neat. An interesting little side note here is you can either say .parallel stream, as I do here, or you can say .stream and then do a bunch of other stuff. And then if you say .parallel, then that will cause this whole stream to run in parallel. It's a little bit wacky the way it works, and we'll talk about this a bit later when we talk more about parallel streams. But as long as .parallel is called either by calling parallel stream or by having .parallel called somewhere in the stream, then the stream will run in parallel. The whole stream will run in parallel. It's a little bit, the semantics of this are a little bit odd. You can also take an array and convert it into a stream. So here you can see we have an array of strings. So A, B, C, D, E, those are all strings. And down here we're going to say arrays.stream, that's the factory method, and this will go ahead and convert the array into a stream of strings, and then we can go ahead and do something to it. You can use the for each loop to print it out this way, or you can use a method reference and print it out that way. They both do the same thing. Notice, by the way, the technique for knowing when to convert a lambda expression to a method reference, in this case, the parameter that is in each element in the stream is also the single parameter passed to the method in the lambda expression. And whenever you see that kind of a form, that kind of a pattern, then you can replace the lambda expression with a method reference. And your IDE will automatically tell you when you can do that. So just look for a little yellow bar on the right-hand column, and when you push on that, it'll say you can convert this to a method reference, and it'll give you a little orange, I think it's the orange or yellow symbol, and if you click on that, it'll do the conversion for you automatically, which is real cool. You can also use a static factory method called of, and stream.of will convert an array into a stream. So same basic idea that we saw before. We can use for each on these things. Now here's a more interesting static factory method that can be used in some cases quite nicely, but you have to be careful with this. So let me first explain how it works, and then I'll kind of give you the caveat. Don't use this for parallel streams. You should only use it for sequential streams. It'll work with a parallel stream, but it'll be really, really, really inefficient. So use the range method instead. So what basically goes on here is we're going to say, I want to iterate, and here is the initial value I want to iterate starting with. So you can see here we're going to make ourselves an array of big integers with two items, both of which are initialized to 1. Does anybody know what a big integer is? Right. So a big integer is it's a wrapper, if you will, and it essentially allows you to do arbitrary precision arithmetic. So normal ints, or even integer with a capital I, will only go up to 2 to the 63 minus 1 or something like that, or 2 to the 64 minus 1. It'll go up to a large value, but a pretty bounded value in the grand scheme of things. Big integer will let you go, for as many different values as you want. It'll handle it. So it's obviously more expensive, but it's going to allow arbitrary precision. So what we do here is we go ahead and create an integer array of 2 items, both of which start with the much smaller value of 1. And then, so that's the initial value. And then this is basically a generator that's going to be used to compute the next value in the iteration sequence. And if you take a careful look at what's happening here, we take in f, which is an array, which starts with 2 items of value 1, and we make a new big integer. This is a lambda expression. We make a new big integer, which is a new array of f sub 1, and then f sub 0 plus f sub 1. So, of course, does anybody know what this is going to compute? The Fibonacci sequence, right? So it's going to compute Fibonacci up to 100. And the way this works is once we've computed this, then we go ahead and map this endless sequence to return just the Fibonacci number, and then we limit it to the first 100 of these things, and we print them out. So that'll go ahead and print out the first 100. This is a good example of why the streams support so-called short circuit operations. So obviously, if you didn't say limit, this would go on forever. So you would just keep generating Fibonacci numbers till till your computer crashed or whatever from running out of memory. But by putting limit in here, it'll only compute the first 100 of them. And of course, it's clever in the way it works under the hood. It doesn't create an infinite number and then select the first 100. It keeps track as it's going, and it stops computing after it hits 100. So limit is what's called a short circuit operation. That's one of the reasons why this is tricky for parallel computations. So don't use parallel computations for that. Here's another interesting factory method that creates a stream. What this does is this particular method called lines is going to be used when you open a file name. So we use paths.get file name. That's going to open up a file for reading, and then we're going to go ahead and convert each line in the file into an element in a stream. So we end up with a stream of lines, which we then print out. So this is a way to convert a file into a stream. Here's another way of doing this. There's another method. I don't know why there's multiple of these, but there's another method called files.lines. So over here you can see we were opening the file and turning it into a file reader, and then we were doing lines on the reader. Over here you can say file.lines, and that will also go ahead and convert a file into a stream of lines, which we then print out. Here's another interesting use case. There's a method on the random number class. So there's a random number class called random. Surprise, surprise. And you could say random.ints, and this will then generate you a stream of random numbers between 0 and 100. So it'll create you random ints between 0 and 100. And then we limit ourselves to the first 50 random integers between 0 and 100. So that's basically how you can generate a stream of random numbers that are within a certain range and print them out. Let's see. There's a bunch of other ways of creating streams. I won't go into all of them, but here's another one. I use this all the time for the test programs I write. This is really cool. What it does is this will take in this particular example here. Oops, there we go. This example here is going to take a regular expression, and it's going to compile that regular expression into a pattern matcher. So you might pass in a splitter, which could be like, I'm going to split on spaces, I'm going to split on new lines, I want to split on some phrase, whatever you want to split on, you give a regular expression, and it compiles that into a regular expression pattern matcher, and then you say, use this splitter to split the input as a stream. And so what we do here is we're going to basically, this is kind of crazy, we open up a file, and we are going to then read all the bytes in that file. We're going to make a new string. So now we have a string that contains all the bytes of the file. And then we take that string and we split the string according to the regular expression. So we'll end up with a stream of input strings, as you can see, a stream of input strings whose values have resulted from splitting the input according to the regular expression that we passed in. And that turns out to be remarkably useful for doing certain kinds of text processing. I use it all the time in my test programs when I have the works of Shakespeare and I want to split based on acts or scenes or whatever I want to split on. So it's a really useful thing, and it's very powerful. Java 9 actually adds a whole bunch more stream-bearing methods to almost everything that's a collection or a container can be split and turned into a stream. And I think this is the last example here. This is a kind of a cool method called generate. And what generate does, as the name implies, is it generates a stream based on some factory you give it. So what we're doing here is we're giving it a factory which is a constructor reference. So this will go ahead and make a stream of tree maps that map long to string. Could be anything, right? We're just providing a constructor reference that knows how to make a new tree map. And we're going to go ahead and generate them, and then we limit it to the first 100 tree maps. So what, tree map, replace tree map with whatever you want to generate. You can generate some number of them, and then we go ahead and collect them and turn them into a list of tree maps. So that's a way to generate a particular number of these things. And this actually turns out to be a little cleaner, in my opinion, than some other techniques for doing this, because if you work with normal Java arrays, some wacky things about Java arrays where you first have to create the array, and then you have to go ahead and go through each element and make an item to go in each element location in the array, which I've always thought is kind of weird. But using this idiom, you can kind of combine those things into one expression or one stream that does it all for you under the hood. Okay, and we'll see some examples of how to do this kind of stuff later in some of the test programs we talk about. Yes, Matt? Oh, sure. Yeah. Well, let's go back and take a look and make sure. So, well, I take it back. We'd have to look. I don't know if you can run that in parallel, because I don't know if there's any place to say to do it in parallel. We'd have to look at the signature to see if there's a parameter you can pass in to say, do this in parallel. It may not work in parallel. Having said that, as we'll see later when we talk about splitterators, you can write a splitterator that runs in parallel that will split a stream. And you can use regular expressions to split it. But I'm not sure if split as stream will do that. But you can certainly use regular expressions to take input and split it up into a stream of split elements using parallel processing, for sure. And we'll take a look at that. Okay, so that's kind of the end of the discussion about factory methods.